Hi there. Today we're going to speak about inverse functions. Now, you'll recall when we started speaking about what a function was, we learned that a function is something that has one-to-one communication going from the domain into the range. So you'll recognise these parts of the arrow diagram. In this, at the very top of the page here, in this diagram, section A represents the domain and section B represents the range. So in order for me to show what a function is, then it's just something that goes from the domain to the range. However, every function always has an inverse, i.e. a way to get back from the range to the domain. And we call that the inverse function. Inverse is just meaning opposite. This is the reverse process of it. To show the inverse function, if we have a function f of x, then to give the notation for the inverse function, we say that it has notation f to the minus 1 of x. So let's look at creating inverses. The inverse of something is just the opposite process. So if, for example, I have the function f of x is equal to 2x, 2x means 2 multiplied by x. So the inverse process to multiply x by 2 is 2 divided by 2, i.e. multiplied by a half. It gets a bit more complex when you've got more than one term in terms of the function. So let's look at example 9 here. Example 9, I want to find the inverse function for f of x is equal to 2x plus 5. Now, to do this, what I want to do is I want to make my formula as simple as possible. And the whole process of finding the formula for the inverse is really just a clever changing the subject of the formula question from National 5. If you can cope with changing the subject of a formula, then you can do this very, very easily. So, what I want to do, because I've got so many x's going on here, I don't want to confuse myself. So instead of it being f of x is equal to 2x plus 5, I'm going to make this function here say y is equal to 2x plus 5, purely to make it easier on myself. So what I want to do here, when I want to find the formula for the inverse, I want to change the subject of the formula to make it say x equals. So to do that, in this case, I'm going to take my 5 across and then divide by 2. So I get y minus 5 is equal to 2x. And therefore divide both sides by 2. I get y minus 5 all over 2 is equal to x. I like to just swap it round so my x is at the front. You don't have to do that. I like my x's to be on my final line, the formula to lead from the left. So I'm going to swap it around and say x is equal to y minus 5 over 2. But the final thing that we have to do here, and this is very, very important that you do that. This is a function, it's an inverse function. So we replaced the f of x with y. We now take our leading subject, which is x, and we're going to replace that with f to the minus 1 of x. So when you do this, once you've changed your subject, you must always put the inverse notation back in. So the leading x becomes f to the minus 1 of x. And because it's a function in terms of x, any other variables become x's. So the y becomes an x. So we get x minus 5 over 2. And that's the function f to the minus 1 of x is equal to x minus 5 all over 2. Example B. We've got g of x is equal to a half bracket x minus 9. So let's do the same process. Let's change the g of x into a y. So that's going to be y is equal to a half bracket x minus 9. So two ways you can do this. You can either multiply through by the half, or I think the simple thing to do is just to get rid of the fraction and multiply the entire equation by 2. So let's do that then. So we get 2y is equal to x minus 9. And again, remember I want to get my x on its own. So I'm going to take my minus 9 across, and it becomes a plus 9. So we get 2y plus 9 is equal to x. I like to swap it back round, as I've said. So we get x is equal to 2y plus 9. And remember, at this stage, we change the x to the inverse notation. So x becomes g to the minus 1 of x. The y becomes an x. So we get g to the minus 1 of x is equal to 2x plus 9.